In today's lesson, we are going to be looking at the factored form. So we've been focusing primarily on the vertex form of a quadratic. We're going to be looking at another form called the factored form. So is the graph of y equals 2x plus 1 times x minus 5 a parabola? And if so, in what direction does it opening? And then we want to find the following: the vertex, the axis of symmetry, the direction of the opening, and the x-intercepts. So I've already gone through and graphed this equation using technology, and we can see here that this equation does form, or this equation does form or graph a parabola. And the direction that it's opening, I can tell already it opens up. If I want to go through now and look for the axis of symmetry, or the vertex, right? The vertex is down here. This is the point 2, -18. All of this I'm just getting from our graph, our parabola here. So our vertex is 2, -18. Our axis of symmetry, that vertical line that goes through our vertex, or it's the x value of the vertex. So in this case, our axis of symmetry is x equals 2. And then our x-intercepts. So our x-intercepts are again where it crosses the x-axis. So here I can see +5, or I can say 5 and 0. And the other one would be -1 and 0. So looking at this, right, is there any connection between the equation that we see up here and the graph and these kind of key points that we've looked at? Well, we might notice, let me do this in green, opens up, right? We have an a value of 2. So an a value of 2, or we might say it's positive. Right? We have a number out front, right? It's multiplying, that's positive, that might indicate that it opens up. The x-intercepts, we see them from the graph, but in the equation, it's actually the opposite of the values in the brackets. And then where is the axis of symmetry, right? Where do we see the axis of symmetry? Well, we can see where it actually is, but it is also in the middle. So it is in the middle, or we might say halfway between x-intercepts. Right, this axis of symmetry is halfway in between these two x-intercepts. Right, so this form, or this equation, does give us a quadratic, or does give us a parabola, and it does give us some key pieces of information. It does give us some other pieces of information than we might see in our vertex form. Our vertex we'll talk about in a second, right? But if we find the axis of symmetry, then we kind of know where our vertex is going to fall. We just then need to figure out how far up or how far down, but we'll touch on that in a second. So this form, y equals a x minus r times x minus s, this is what we call the factored form, right? And the factored form has 3 different variables, a, r, and s. Now the a value is the same as the vertex form. So this tells us our direction of the opening, the stretch or compression. It gives us the step pattern. So this a value is the same as the vertex form. So everything we know about the a value stays the same. Now r and s are different, right? R and s are actually the x-intercepts, because that is what this form gives us. This form gives us the x-intercepts. So it's another kind of way that we can graph this, or it gives us some other key pieces of information. So we're given the x-intercepts. Now, one thing to note, Similar to the h value, because this general equation has a negative in it already, our r and s, or the x-intercepts, are opposite of what we see. Now, having the x-intercepts is helpful, right? Because when we start looking at applications, it will give us a key piece of information, a different kind of information, or might give us a different application to it. But it also can help us find the vertex. So while it doesn't tell us the vertex explicitly, like the vertex form does, just picking out the two values, since we know the vertex is in the middle of our parabola, in the middle of our quadratic, or of our graph, if we have x-intercepts on either side, the vertex is going to be located halfway between them or in the middle. So if we know our x-intercepts, we can find the rough location of our vertex and then use that information to find the exact coordinates. And that's what we're going to be doing. So we want to find the y-intercept where it crosses the y-axis, the zeros, which is another word for x-intercepts, the axis of symmetry, and the vertex for the specific quadratic relation y equals 4, x minus 4 times x minus 2, and then we want to sketch a rough graph. So the first thing we're going to do is find the y-intercept. And the y-intercept is when it crosses the x or the y-axis, and it's when x equals 0. So when it crosses the y-axis. So I'm going to take my equation, y equals 4, x minus 4 times x minus 2. And to find the y-intercept, I'm going to sub in x equals 0. So everywhere I see an x, there's going to be a 0. So 0 minus 4 times 0 minus 2. Now I can just go through and solve or calculate. So 4 times negative 4 times negative 2, because 0 minus 4 is negative 4, 0 minus 2 is negative 2. So 4 times negative 4 is negative 16 times negative 2 is positive 32. So therefore, my y-intercept is the point 0, 32. Right? The x value is 0. The y value that we got using this equation was 32. Now for the x-intercepts, it's a little bit different. Right? The x-intercepts, where it crosses the x-axis, it is the same thing as, or it's kind of the opposite of the y-intercept. We're going to look for when y is equal to 0. So if I have my equation, y equals 4, x minus 4, x minus 2, if I make the y value 0, I have 4 times x minus 4 times x minus 2. We haven't solved an equation like this quite yet. But if I think about numbers multiplying to 0, right? If I have numbers multiplying to 0, the only way to multiply to 0 is if one of those values or one of those numbers is 0 itself. So to multiply and get 0, one or both values need to be 0. So if I'm looking at this expression, 4 is 4. 4 can't be anything else. It is 4, right? It's explicit. It's 4. Now, x minus 4, this bracket, there's a value here, right? So there's an unknown value for x in the first bracket. There's an unknown value for x in the second bracket, right? So there are values for x that might make the first bracket 0. If the first bracket is 0, then it doesn't matter what the other two are. This will give me 0. If the second bracket works out to be 0, then it doesn't matter what the other two are. The whole thing will be 0. So there are different ways that we can look at this, right? And the ways we can look at it is essentially we want to look at the brackets. We can use the shortcut because we did talk about kind of the factored form and what our x-intercepts are up here, right? Just the r and the s value. Or we can mathematically look at it and say, okay, well, if I want the first bracket to equal 0, x minus 4 equals 0. Let me just write it a little bit bigger. And if I solve for x, x is equal to positive 4. So that means one x-intercept will be the point 4, 0. For the other one, x minus 2 equals 0. X equals positive 2. Move the negative 2 over, it becomes plus 2. So I have a second x-intercept of 2 and 0. And you can see how we get just taking the opposite of the values we see in the bracket. Negative 4, our x-intercept is positive 4. Negative 2, our x-intercept is positive 2. So you can go through this long way, and in some cases you might have to, depending on the x-intercept that we get. But other than that, you could just take the opposite of these, the r and the s in the brackets. So the next step is to find the axis of symmetry. And the axis of symmetry is going to be halfway between our two x-intercepts. So we had mentioned if our x-intercepts, just hypothetically say, are here and here, our axis of symmetry is going to be halfway in the middle. So somewhere in the middle that is directly halfway. So what we can do is we can take our two x-intercepts, or we can say the AOS, the axis of symmetry, it's going to be x is equal to sorry about that. There's a little glitch in my program here. So the axis of symmetry is going to be x is equal to, right? Because the axis of symmetry is going to be a vertical line, x equals, and the values are going to be the average of our two zeros. So we're going to add our two numbers up. So if I go back, 4 and 2 were my two x-intercepts. So 4 plus 2 divided by 2, I get 6 divided by 2, or 3. So therefore, my axis of symmetry is x equals 3. Now, in this case, you might have said, well, of course, the middle of 4 and 6, or 4 and 2, is 3. 3 is halfway in between. You might not have to calculate it. It might be very straightforward. But in some cases, it might not be as nice of a middle number. So I would definitely recommend still going through and showing this step, just because it will be helpful to know this when you look, or when you get some scenarios that aren't as nice. Now that we have the axis of symmetry, now we can actually go through and find the vertex, right? So we already know what the x value of our vertex is, and we got that when we found the axis of symmetry, right? We know that the axis of symmetry is that vertical line that goes through the vertex, so that means the x value of our vertex has to be the same as that axis of symmetry, or 3. Now we just need to find the y value. But if we know part of our point, our coordinates, if we know one coordinate, I can plug the other coordinate in, or I can plug that coordinate in and find the other value. So I can take my equation, y equals x minus 2 times x minus 4. I think I have those backwards. Not that it really matters, but just for consistency so no one gets thrown off. Yes. So I have my quadratic. I have a value for x, or I want to find the y value when I know x is 3. So I'm going to substitute that in. So that 3 comes from the axis of symmetry. So y is equal to 4 times, and now it's just a calculation. I'm going to solve my brackets first. 3 minus 4 is -1, times 3 minus 2, which is +1. 4 times -1 is -4, times 1 is -4. So therefore, our vertex is -3, -4. The y value is -4 when the x value is 3. Now that we have all of that information, we can roughly sketch our graph. Now, if we really wanted to, we could graph it accurately because we do have the vertex and our step pattern. right? We have the a value from our equation, so we could start at our vertex and then follow the step pattern. But because it just wants a sketch, I'm just going to roughly plot my points. So one x-intercept, which is 2, 0. Another one, which is, it's a little too far, 4, 0. My vertex was at -2 and, or sorry, 3 and -4. So let's just say down here. And we know it opens up. So my parabola is going to look something like this. Again, rough sketch, not accurate. If we wanted to be accurate, we have the specific coordinates. We have an a value, so we could do the step pattern, but we have enough here just for a rough sketch. So let's go through and do the same thing with the next one. Right? We're going to go through and find the same pieces of information. Y equals x minus 2 squared. I'm going to rewrite that. Y equals x minus 2 squared. Right? This is just the same thing as saying y is equal to x minus 2 times x minus 2. First thing we're going to do is we're going to find our y-intercept. So to find our y-intercept, we're going to say that x is 0. So in our equation, y is equal to 0 minus 2 times 0 minus 2, -2 times -2, or y is equal to 4. So therefore, our y-intercept is 0, 4. Next thing we're going to do is we're going to find our zeros, or our x-intercepts. Our x-intercepts are when y is equal to 0. And again, sorry if you just saw a change. For whatever reason, the size of the pen decided to change automatically for some reason. I don't know if I pressed something or if the software is just going on me. But anyways, x-intercepts are when y equals 0. So there's two different ways we could do it. Because we have our equation, y is equal to x minus 2 times x minus 2. I could look at and say, okay, well, we have an r and an s value. That's my r, that's my s. So the x-intercepts are just going to be the opposite of those values. So in this case, the x-intercepts are going to be 0 and, or sorry, not 0 and 2, 2 and 0. Right, that is the only coordinate, or I could say, well, it's 2 and 0 for the first one and 2 and 0 for the second one. Right? Opposite of what we see in the bracket. What we could also do is we could also set each bracket equal to 0. X minus 2 equals 0, x minus 2 equals 0, x equals 2, x equals 2. So because we get the same value, right, we have only one x-intercept. So I can actually just erase that and just say the x-intercept is 2. After the x-intercept, we want to find the axis of symmetry. The axis of symmetry is the halfway point between these two values. So x is equal to 2 plus 2 divided by 2, or 4 over 2, or 2, which makes sense. If I don't have 2 points that are different, right, there's not going to be a middle value. So when I have the same point, the middle value is that point. Now that I have the axis of symmetry, now I can go through and find my vertex. So my vertex is going to be the point 2 and something. So in order to find out what that something is, I'm going to take my equation, y is equal to x minus 2 times x minus 2, and plug in the value of 2. So 2 minus 2 times 2 minus 2, we get 0 times 0, or 0. So therefore, my vertex is the point 2, 0. Now, if I want to sketch, where can we sketch? Let's just move this up a little bit. Let's try to organize this a little bit nicer. we go. So a little bit nicer, more organized here. So now if I want to sketch this quickly, right, I'm going to sketch, right, just roughly draw my axes. Again, doesn't need to be in any particular way. We have a vertex at 2 and 0. This also happens to be our x-intercepts. So again, I don't need to put any other points here. I do have a point at 0 and 4. So if I want to put that one there, I can. It does open up, right? Because my y-intercept is here, it does have to open up. So I could argue, okay, well, if 0 and 4 is here, then that means that on the other side, because it's symmetrical, I should have a point here, which would have to be 4 and 4. Again, doesn't have to be, but you don't have to draw that one because we're just sketching it. As long as we have just something that looks like that, that would be an appropriate sketch, right? It's just, again, the rough sketch is just to have an idea about what our parabola looks like. So next we're going to try to determine an equation for a graph that's already done for us, right? Or for a parabola that we've already mapped or graphed, right? Maybe we're tracking something and data shows this graph. We want to come up with an equation to model it, right? We want to come up with an equation to make a prediction for it, right? So what we're going to do is we're going to look for the zeros. So the first thing we want to do is look for the zeros. Right? Look where the x-intercepts are. And the two x-intercepts we have here are 1, 0 and -2, 0. And that's important. Those two x-intercepts are important because we can use these 2 points to fill in some of the information for our general equation in factored form. Right? So if our factored form is a times x minus r times x minus s, by finding the 2 zeros, we're finding the r and the s. So that means in this equation, I can say y is equal to a, x minus -2 or +2. Remember, our x-intercept should be opposite of what we see in the brackets. So if it's -2 in real life or on the graph, it should be +2 in the equation. And if it's minus or +1, it should be -1. So we have part of our equation so far. The only thing that is missing is this a value. Right? We need to know the step pattern. We need to know the direction of the opening. Right? Now, looking at our equation or our graph, we can see that it should be a negative value because it is opening down. So that will be helpful in just verifying if our answer makes sense. The other piece of information is we are given one other nice point. We are given the y-intercept here. We are given a y-intercept of 0 and 10. And now this point gives us an x and a y coordinate. Because if I look at my general equation so far, y is equal to a x plus 2 times x minus 1, I'm missing a, but I can't solve for a because I'm also missing an x and a y. So because I'm missing an x and a y, I need to find a value for those two variables to plug in, and then I can solve for a. And those two values come from a point on the graph. And now we are given a nice point. You want to make sure you're choosing a nice point, that there's no like decimals or things like that, because we want it to be accurate, right? If we're using decimals, then we're probably approximating unless it's a very, very accurate graph. But chances are we want nice whole numbers. So we're going to look for a nice point. We see one here at 0 and 10. So now I'm going to take those values, plug them in. So 10 for y is equal to a times 0 for x plus 2, 0 minus 1. And now we're going to go through and solve for a. So 2 or 0 plus 2 is 2, 0 minus 1 is -1. I can multiply the two numbers. 2 times -1 is -2. Now to get a by itself, I'm going to divide both sides by -2. One side will cancel out, and we're left with a is equal to -5. Again, that does help because we can see that from our step pattern, right, or from our graph, it is opening down, right? So we should, it is opening down, which does make sense. It is a negative value, and it does appear to be a bit stretched, which also helps. So now with that value, or the value that we found, we can state our final equation, which is y is equal to -5 x plus 2 x minus 1, right? And that is our final equation. So when we're trying to determine an equation for a model, right, we have to make sure that we are plugging in a value, or finding our zeros to replace the r and s. Then we're plugging in a point on the graph to fill in x and y and solve for a. Now this step can be done for vertex form as well. If we know what the vertex is, we can fill in our h and k, plug in another point on the graph for x and y, and solve for a. Right? So we can do this with a vertex form as well. This is not limited to factored form. This process, this type of process, is applicable to vertex form as well, which you may have to do in some of the homework questions. So just be mindful of that. We can use the same idea for vertex form, except we're looking at the vertex first and not the zeros.